Alright, so we got a full long day of notes today. We will be taking notes the entire 4 mods today. Sorry, it just happens to be one of those days where we combine two long days into one longer day, so it's going to be a longer day today. So, happens. Okay. So, to recap, last week, Thursday, we were talking about the law of the sines. It was on a pink note sheet that you had last week, Thursday. On the front side, we discovered the law of sines based off of the area of a triangle. And then on the back side, we did 3 examples, and we had a great, grand, and wonderful time doing all of that. We found that the law of sines was the sine of angle A divided by side A is equal to the sine of angle B divided by side B is equal to the sine of angle C divided by side C. And that works on any triangle. It's wonderful because it doesn't have to be a right triangle for SOHCAHTOA to take effect. It can work on any kind of a triangle, acute, obtuse, or right. It will still work on a right triangle. Okay? So with that being said, let us refresh our memories and let's solve this particular triangle for us using the law of sines. I got angle A is 65 degrees. Side C is 11.287. And side A is 14.467. Challengers? Any challenges to that? All right. Good choice. More is better. What do you got?
I don't know.
Are you in radians and not degrees?
No, I'm in degrees.
I don't know what to tell you then, man.
Oh, I wrote 48 over here.
Oh. Probably because you're sitting so far away.
Or I just can't read my own handwriting.
That too. That works. As long as you figured it out. Alright. So, today, just when you think you have all the answers, I'm going to go and I'm going to change up the question. Because that's the kind of guy I am. Okay? So, we're going to talk different ways to solve triangles. Okay? Now, whenever we have to solve a triangle, we have to be given 3 parts of that triangle. Okay? So you're either going to be given 3 sides, or a side and 2 angles, or an angle and 2 sides. Okay? So If we're in that 3-side case, well, then you've been given the 3 sides of the triangle, and you're going to use the law of cosines. Okay? We haven't gotten to the law of cosines yet. Okay? We're going to get to that tomorrow. Tomorrow's law of cosines here. So that one's a law of cosines problem. Same thing as side angle side. When you're given the side and angle, and then the next side, or 2 sides and the included angle, both of those are law of cosines type problems. We're going to get to those tomorrow. Okay? Love it. Okay. Angle side angle. Well, so if I've got an angle, a side, and an angle, how would you go about solving that triangle? What do you got?
Finding the other angle,
Okay, and then what?
and then doing what I did here.
Law of sines?
Yeah.
Yeah. Yep, exactly. Okay, that's a law of sines problem. Bless you. Angle, angle, side. What are you going to do there?
Isn't that the same thing?
Law of sines. Yep, same thing. Find the third angle, use law of sines. Bada boom, bada boom. Love it. Okay. What about if you're given 3 angles? Law of cosines? If this angle and that angle are equal, this angle and that angle are equal, and if those angles are equal, right? Can I solve that triangle? Can I solve either one of those triangles? No, because they're similar triangles. Similar triangles all have the same angles, and they're all different sizes. So we can't solve when we're just given 3 angles. Okay, that's the one we can't have. Have to be given at least 1 side length. So we set the size of our triangle. Okay? Alright. Let's try the naughty case. Okay. So our angle side case. So we've got an angle, we've got a side, and we've got a side. Okay? It's the naughty case. What I'd like you to do is, because we have the one complete fraction, right? We've got this complete fraction, so we can use the law of sines. All right? Find me angle B. Just angle B. Don't solve the whole triangle. I just want you to find me angle B. All right, so what did we get? Really? What you got? What did other people get? What'd you get?
9.28.
Yeah, no, it's not. I haven't heard that one today yet. For angle B? For angle B. Bugsy.
Oh yeah, I got the same.
What'd you get?
6.28. I got 52.216.
So
You can't do it. Didn't it? Yeah. I like swear I remember them saying that you can't. But isn't it? I think the other thing Oh yeah, I remember correctly. Yeah, because they don't want to.
they just didn't want you to swear.
Oh, it's the inverse. Are you kidding?
Oops.
I actually tried to do this.
And what did you say you got?
64.73.
That's what I got too.
You really got that?
Yeah.
I got. What did I get?
Yeah. 64.78. Wait, I bet you did division before you got the two parentheses. Wait a minute. 31 times 5. Oh, you're
That's
telling
180 minus
5. Nope, still didn't get that.
Check mine.
That's not, wait.
Check it. See if mine works. I really want to know. 'Cause
I got 64.783.
I know, but I got 115.217.
Well, if you subtract it from 180.
So check my work. I want to know where I screwed up.
You didn't put the answer key.
Oh, do you put the first? Okay, divide by 5.
It equals
It equals what though?
yeah.
Because they equal each other, don't they? Because I checked my work. Yeah, they do. If you go sine at 20.5 degrees, sorry, I forgot the degree symbol.
Yeah, they do equal.
Check from the.
Have you been telling everybody that
Ruh-roh!
Wait.
That's why it's not possible.
Ruh-roh!
Oh, right? No. Come on.
Ruh-roh! We got ourselves something called the ambiguous case. Okay? Ambiguous meaning open to. So, the ambiguous case being open to multiple interpretations. Hey, focus back in because you need to be focused today. Okay? The ambiguous case is open to multiple interpretations. Now, this will only happen in the angle side case. Okay? If we're on any one of these other ones, there is not an ambiguous case. There's one triangle formed and you just go with it. It's just when you have an angle side case. Okay? So, the first scenario is if the angle that you are given is obtuse. Oops, nope, I want that to be A. Okay? So if your angle is obtuse, come on, work for me. There it goes. If your angle is obtuse and your opposite side is bigger than your adjacent side. Or in this case, B is bigger than A. If that's the case, angle side side, obtuse angle, opposite bigger than adjacent, you get one triangle, and you're going to use the law of sines to solve. If your given angle is obtuse, and now your opposite side is less than your adjacent side, unfortunately, you get no triangle, so you can't solve it. Okay. If our given angle is acute, and our opposite side is longer than our adjacent side, we get one triangle, and we're going to use the law of sines to solve it. It's this next one where things get all cray-cray. If our opposite side, well here let me put in so we have this angle, this is our adjacent side, that's our opposite side. Get all this right away. All right. So if the opposite side, oops, I should label my height too. The height of the triangle is here. Remember, heights are perpendicular. Okay? That's going to be crucial on this particular one. So if my opposite side is the same length as my height, then what do I get? What do we get? If the opposite side is the exact same length as my height, we get a right triangle. Yep. And how are we going to solve the right triangle? What do we use in right triangles? Am I going to use the law of sines? I only have one side. Actually, no, I do have two sides. So I could use the Pythagorean theorem. And could I just use SOHCAHTOA instead? Give me my other stuff. Okay? That's the easy scenario. If my height is longer than my opposite side, so I'm in this scenario where my height is longer, how How many triangles do I have? None. If my opposite side is longer than my height, now notice what happens. If I swing that like a pendulum, how many triangles do I get? I get one there. And I'd get that one there also. So I get two triangles in this case. That's like this back here. Our opposite side was shorter than our adjacent side. So we checked. If we would have found the height of our triangle, it would have been shorter than our opposite side, and so we ended up with two triangles. Blue and green would be angles in the two different triangles. Okay? So, to wrap all of this stuff up into one quick and easy slide. Remember, this only happens in the angle side case. Okay? If your opposite side of the two sides that are given, if your opposite side is bigger than your adjacent side, you will always get one triangle. And you can always use the law of sines. Okay? If the roles are reversed, if your opposite side is shorter than your adjacent side, then you're going to get 0, 1, or 2 triangles. So the first thing that you need to check is you need to check your angle. If the obtuse angle is given, no triangle. If your angle is acute, then you need to check the height. And if the height is equal to the opposite side, one right triangle. If the height is longer than the opposite side, no triangle. If the opposite side is longer, two triangles.